All right, so writing expressions here. When we go ahead and write them, we want to think about what the problem is telling us, what we know, and what we don't know, and kind of put that all together. So this we're going to write on, so you can right click, save to keep. We'll open it up in a new tab. We'll click and click again until we get the pen. And here we go. So in the first problem, we have two birds, bird A and bird B. Bird A, it says, is flying 9 meters higher than bird B. And we need an expression for bird A. So if we already knew what B is, we don't. So I'm going to put a variable. I'll just put a B because, bird B. You can put something different if you want. It doesn't matter what letter you use. It says bird A is 9 meters higher than that. So I need to think about what higher than means, what it's going to tell me. That's, to be higher means you're up more, so that should be an adding thing. So I'm going to add 9. And that's it. That's going to be my expression that I have there. So I'm kind of reading the problem, figuring out what the variable is, and then what I do with the variable to get to my answer. So eventually, the point of having this expression would be if we had more information. Like if you knew that bird B was flying at 20 meters, then bird A would be at 20 plus 9. So we could kind of go and use that to help us in the future situation. If you look at number 2, it says Ty's car is driving at 15 miles per hour slower than Jim's car. So we need an expression for Ty's car. So we also don't know what Jim's car is, so I'll maybe call it a J because, Jim. And it says Tyler's car is slower than that. So if you're slower, I have to think about what operation that would be. I want to get less, right, to be slower, so smaller number. So I'm going to subtract, and it said 15. And that's going to be my expression for the second one. For the third one, it says Jen's sister is 9 years older than twice her age. And so we can write an expression for Jen's sister's age. So this one's going to have two operations in it, right? Because you have the 9 years older, and then you have twice her age. So I need to think about the older part, and I need to think about the twice part. We know that the variable then is going to be how old Jen is. So we could put a J. Then it says Jen's sister is 9 years older. So older should make my answer bigger. So I'm going to add. Then twice her age. So twice is one of those words that means 2 times. Jen's age was J, so we have 2J or 2 times J. And I want that to happen first, which it will, because multiply comes before add in order of operations. So 2J plus 9. For number 4, a real Gucci necklace is $9 cheaper than 4 times the price of a knockoff. So write an expression for the price of the Gucci necklace. So we have here the 4 times, and we have cheaper. So those are going to give me hints about what operations I need. So the knockoff costs some amount of money. I'll put K for knockoff. And the Gucci is $9 cheaper. So that should be less, which means I'm going to take away 9. Then 4 times the price of the knockoff. So I have 4 times K or 4K for my answer there. So 4K minus 9 gives me my answer for number 4. So one thing that we need to be able to do is to just write an expression based on a situation like the ones that are there. The other thing that we need to be able to do is think about, especially using some of the simplifying things that we were practicing in the last unit, how different expressions that still work for the same thing connect to each other and show us different information. So over here, you have a poster that the student government made for a school dance, and you can see there's some different dimensions that are listed here. So some kid named Brett thinks that the area of the poster is the product of the total length and the total width. So we could find the whole area, right? I do length times width for a rectangle. So I need the whole width and the whole length. So in the first one, if I'm going this downside here, it already has a 6, right, which they wrote up here. So the other number that goes with 6 would be 3. So Brett's saying we could do 3 plus 6. And then if we do the other dimension, they're going up and down, right? I have 8 and 4. So they already wrote 4 for me. So then I also have 8. And so that would be one expression we could use to get the area of the whole poster right off the bat, just using the dimensions there. But the next part is really the kind of advanced 7th grade thinking there, which is how else can we do the area of the whole poster? And what does that tell us differently than what this one did here? So what Kai wants to do is to think of the area of a poster as the sum of the areas of 3 sections, right? Because if you look at it, there's a part that says event title, a part that says picture, and a part that says information. So because of that, then, Kai's going to find the area of each one of these pieces. So we need to write an expression there and then tell you what Kai's expression lets you see that Brett does not. So if I look here, there's the 3 parts. So I could start with the event part, right? Which is 3 by, how high would that be there? Well, I have to put those 2 together, so I'll do it kind of similar to Brett's there, right? That would be 4 plus 8. Then I have another section, so that's an adding thing. And we could do the picture. Well, the picture is 8, and then down here, I have to go down to here. It tells me this much is 6. So 8 times 6. And then I have another one, so another plus. And we need to find the information section, and it says this one is 6 by 4. So 6 times 4 for that part. So that would be another expression. And if we simplified both of these, and assuming we put things in the right spots, we should come out with the same answer. So the question, or the next question that's here is really, what can we see in Kai's that we can't see in Brett's? And so I'm really thinking there's kind of 2 parts here. One thing that I can see in Kai's that I don't see in Brett's is that there are 3 parts. Because Brett just does the whole thing all together, right? The fact that we have to add some dimensions might tell us it's divided, but if you didn't have this picture, Brett's expression wouldn't tell you that there were 3 pieces. Whereas in Kai's, I can see pretty easily there's this piece, and this piece. So 3 sections. And you would know that they're not equal either, right? Because their dimensions are different. So 3 parts, not equal, right? That we have there. So that's kind of one thing that we're really seeing here about Kai's expression that isn't in Brett's expression. So if you wanted to be able to communicate that information, then that would be the expression you use versus Brett's expression, even though both of them get you the correct answer. So I'm going to go back and put this in my math notebook. I'll make it a little bigger so I can see it. So remember kind of both things with expressions that we're talking about. How do I write expressions using the information in the problem? And then how could I write different expressions that tell me different amounts of information based on what's in the expression?